record some of this as well. I'm so forgetful. Yeah. All right. So what this is showing is it says let angle A be an acute angle in a right triangle. It's saying that if tangent of A equals X, then basically if you want to find out what A's value is, you would have to do, this is called inverse tangent of X to get A. If you know that sine of A equals X, well then what you'd have to do, now notice what's kind of happening here. Here the A has the sign, right? Does the A have the sign anymore?
No.
Where did it move? It moved over with the X, but is it still sine? It's called inverse sine. Inverse sine. And the same thing happens here. Well, to go further with it, if you have a triangle, this is to show you that, you know what? If you're dealing with tangent of A, you're still going to be doing opposite over adjacent to get that ratio. But then what you can do to find the measure of angle A is you're going to do an inverse tangent of that ratio. Sine, inverse sine of the ratio. Inverse cosine of the ratio to get you the angle. Well, like I said, I kind of feel like this is a little bit overcomplicated. So let's look at an example and let me show you how I think about this. How I think about this is, well, and they've got some more information here saying that this means I want the angle A whose tangent is X. You don't even need to worry about that even. I want you to approach these problems the same way that you've approached them so far. And a lot of you did pretty darn good on that quiz. So I want you to approach them the same way. On example 1, it says, use a calculator to approximate the measure of angle Q to the nearest tenth of a degree. Well, which angle are we talking about?
Q.
Q. Guess where I'm going to stand?
Q.
I'm going to stand at Q. And I'm going to look around, and I'm going to decide what sides I know. What's 12 in relation to where I'm standing?
Opposite.
Opposite. What's 8 in relation to where I'm standing?
Adjacent.
Which trig ratio uses opposite and adjacent?
Tangent.
Tangent does. So you're going to say tangent of Q. We don't know what it is, do we? We're going to say tangent of Q. Maybe we should say like tangent of angle Q, maybe. But tangent of Q is going to be equal to opposite over adjacent. Well, this is all well and good, but what am I trying to find the value of? I'm trying to find the value of Q. Well, to do that, I, in essence, need to undo this tangent. And how I undo it is with an inverse tangent. So it's kind of like you're doing an inverse tangent of tangent Q, and what that does is that gets rid of the tangent, and guess what you're left with?
Q.
Q, or measure of angle Q. But when you have an equation and you do it to one side, what do you historically always have to do to the other side?
Multiply by
Same thing. Now, I'm not multiplying here. It may look like it, but I took an inverse tangent of a tangent. Well, over here, I'm going to take an inverse tangent of 12 over 8. So I'm undoing the tangent, but I got to do it on both sides. Is everybody with me on that?
Yes.
And so what we have here is inverse tangent of 12 over 8. And oftentimes people will put like a parentheses there. Do not mistake this for multiplying. Tangent is not a multiplication endeavor. Tangent is just recalling a relationship from your calculator. So this is saying inverse tangent of 12 over 8. And you grab your calculator. Has everybody got one? You grab that calculator. And I don't use this calculator too often. I'm probably gonna gotta do it. Okay, so do you guys see sine, cosine, and tangent?
Yes.
Do you see above them? What do they have? They have the inverse, don't they? So on my calculator, I'm gonna do 12 divided by 8 first. And then I'm gonna go shift inverse tangent. And I'm there. I am there. Is everybody else there?
What do you want us to round?
I think it tells us.
Oh, okay.
What do you want to round to? Nearest 10. So what's our answer, everybody? 56.3. Measure of angle Q is equal to 56.3. Oh, 56.3 what?
Degrees.
Degrees, yeah. There's also like radians and stuff, so it's important to put degrees there. Question.
How did you get from 1.5 to 56.3?
I did the inverse tangent. So I got 1.5, and then I go shift inverse tangent. On your calculator, you're going to do inverse tangent 1.5. Yeah, you got to do yours in a different order. Is everybody cool with their calculator and know what's up with it? Alex, yeah, let me see. Let's see here. Okay, so let me see. Inverse second. Boom, there you go, yep. Now I've had some people today try to put a multiplication in there. There's no multiplying, is there? There's no multiplying. You're just finding the inverse tangent of it. So it looks like some people are going to be leaving here pretty quick. But let me just show you real quick. If you're at sine C equals 0.24 and you want to solve for C, you're going to go measure of angle C is equal to what?
Something.
I really don't want to write out. What's that?
The inverse of sine.
The inverse sine of what?
124.
0.24. Yep. That's all there is to it. And then punch that in your calculator. 0.24.
13.9.
Inverse sine. I like it. Measure of angle C is equal to 13.9. 13.9 what?
Degrees.
Degrees. So we'll pick up more on this tomorrow. Bye, bus riders. Catch that bus. Bye. Public transit is good. Use it. You don't have to pay insurance on a car, you know? Don't spend money on gas.
That sounds thrilling.
Yeah. Public transit. Where you live doesn't offer public transit, move, you know?
Well, yeah, but when I have to drive, it won't take 40 minutes to get home. Instead, it'll take 10.
That is the reason.